Yeah, sure. Hi, everybody. Thanks for coming. My name is Aren. We're here to talk about reducing mixtape to master key scenarios, blocking the dark army using API-driven access control. This title makes no sense. We're about to explain it and talk about why. Can you hear me? Is that better? All right, thank you. So I should speak up. I'll shout. All right. So a little about me. I'm the founder of BoxPass. We're a new DevOps security company. We focus on infrastructure, identity, and access control. And we build a product kind of like what I'm showing you today, but we think it's so important that we want to show everyone how to build it for themselves as well. Previously, I had various engineering, operations, and security roles at Pinterest, Bebo, Oodle, Danger, if you've heard of any of those places. All right, so let's talk about this title. Defining what do I mean by mixtape to master key. So first, what is a mixtape, if anyone remembers? Right, the old cassette tape on the left there, mixtape. So the theme of B-Sides was Mr. Robot, so I tried to pull my title from, I might be the only one who actually did this. But, right, it's like being invited to a costume party. But, a party when you're not, it's from Legally Blonde, right? Yes. Anyway, thank you. So in Mr. Robot, in the first season, someone correct me if I'm wrong, but Cisco, who worked for the Dark Army, was trying to phish someone who was at Allsafe, and so he's handing out his mixtape, trying to get him to put it in the CD at the office, and succeeded, right? So it might as well be a malware USB key left in an office's front door. Same idea. Somebody got phished, so that's the mixtape, right? Sad face. And master key, fairly straightforward, right? Master key is a key that can open any lock. And in this context that we're talking about today, it's if you have root on any host. So basically, how do we make sure that we don't leak keys that can get you root on any host? Title make more sense now? Awesome. All right, so how are master keys created? Oftentimes, by default, like a company is going to have two levels of access. You either have no access or you have full access. And I see a lot of heads nodding. It's actually pretty normal practice. So either you're an engineer at this company or you're anybody else. It's either yes or no. So we're going to talk a little bit about why this is not the best policy. But even at companies where they do have granular access, pretty soon an employee is going to have collected them all. So it's like Pokemon, like gotta catch them all. You end up with every single permissions, which just gives you the. All right. So why are they dangerous? Pretty self-explanatory. Guard against a malicious employee, sort of the least likely. Phish stolen credential, pretty likely, or somewhat likely. And I was putting this slide together. I thought to myself, one of the big benefits of what we're talking about today is just preventing employee mistakes. Like if you're not supposed to be on a host at that time, then maybe it'll prevent you from being on that host accidentally. So, a lot of examples, even in my career, of someone thought they were deleting the dev database, and there goes staging if you're lucky, there goes prod if you're unlucky, right? This happens a lot. It's happened to me, in my teams, in my career. So there's a lot of value just in that last slide.
Security professionals to guard against ourselves as much as guarding against the outsiders. All right, so the alternative to master keys that we're talking about today is just to make sure that if you get a permission, it has an end date, or there's something that's going to cause that permission to end other than you leaving the company. If your access is not ending when you leave the company, that's a very different problem, way more important. There should be some end event, time-based, some activity that happens that we could talk about, that permission goes away. And you want these to be short. Ideally, it would be you can use this token to log in once, and then you can never log in again unless you get that permission again. There's a whole spectrum here, but the idea is that they all expire. And as I just said, the sooner the better. Maybe you could measure that in days, maybe it could be hours, maybe it could be minutes, or maybe there's some other event that's going to require this access to go away. All right, and let's answer this question. When should these permissions expire? So the obvious ones, you leave the company, of course. If you put an actual time value on that permission, this expires in an hour, this is gone in a day, this one's gone at the end of your consulting arrangement with our company. But there's some other ones that are a little more dynamic that we can talk about. So this is granted until your on-call rotation is done. So when you're in PagerDuty and you're on call, then you're going to have a permission. And when your week is up, a lot of this access is going to go away. Or, all right, oh, we're back. All right, there's a JIRA ticket that maybe has to be open for you to have some access. It's been granted, approved, it's in process, you have that access, you close the ticket, the access is gone. Or something really, really clever, right? You didn't use this permission enough, and now it's gone away. Right? We call this use it or lose it. If you're not using something, you clearly don't need it, it's going to go away. All right, I sold you, you want to build this? Cool. Let's talk about actually how you go wire this up in your environment. Authentication versus authorization. You know, we have passwords and keys. They're really pretty good at telling us who you are. And then oftentimes we miss the authorization step. So we know who you are, but now what can you do? And the traditional systems to set this up usually, right now, is you got Chef, Puppet, Ansible, Salt, these sorts of things. Your config management tools. You know, you have scripts in there to edit your SSHD about allowed users, allowed groups. You can fix up Etsy group about who's in the sudo, who can log in as different users. This works. It's pretty pervasive, but it's very slow. Right? If you want to make a change to your access, right, you check out the repo from GitHub. You check in your change. Maybe you get it code reviewed. You push it out to the GitHub repo, and then maybe Chef server picks it up. Then maybe you have to run knife. Right? It could take a long time. We're talking about things that are much more dynamic. Some people will switch to an LDAP server, right? A lot of overhead to set these up, unless you use a cloud provider like us. And they're somewhat inflexible. It's harder to set up per host rules, who can be on what kinds of hosts as well. And then what we're going to talk about today is doing this with SSH keys. So conceptually, it's pretty easy. If you have your config management puts every user on every host already, but there are no SSH keys, then that user can't log in. And you can manipulate the SSH keys to figure out who's allowed to log in as what users. Excuse me. All right, authorization with SSH keys. This should look pretty familiar. Two examples here of my authorized keys file and root's authorized keys file. Right, so you open this file up, add someone's public key, remove someone's public key. Don't make any mistakes. You're going to get locked out of this machine. I've been there. Anybody else? Yeah. Be careful. But conceptually easy, right? Add, remove keys. You've decided who can log into this machine. So that's really the crux of what we're talking about today. All right, so if you do it manually, it's a lot of work. What else you got? Well, I'll show you what we got. Let's make a centralized SSH key server to decide what keys are on which hosts under what users. So go spin up a database, MySQL maybe. We're going to put everyone's SSH keys in there, so we have a little web UI. Everyone in your company who's allowed can log in, manage their own keys, so when they get a new laptop, they're not going to come bug you to put their new SSH keys in GitHub. Usually you just make a little web front end using OAuth to auth against your Office 365, your Google Apps, whatever you already have. Upload their public SSH keys. All right, now we've got our database. Now we're going to talk about, once the keys are in that database, how are you going to get them onto your Linux server? So, a lot of options here. One of the obvious ways is to just put an agent on every machine, right? Agent will query the database periodically, pull those keys down, write them on to the proper authorized keys files on disk. You're golden, right? So this works. It's a little fragile if that code breaks. If it runs out of memory and you don't load any keys in that machine and you can't load any keys anymore, that could be bad. And another problem is it could pull we want to make changes that are by the minute, definitely several times an hour. If you have all these machines polling this one little API, it should have two really, it's a lot of load when you're only making changes periodically. So we're going to switch this from a polling model to more of an on-demand model. And here's how to do it. Inside of SSH deconfig, there's this new command as of 6.2, I think, SSH, where you can give it a command that we write to return keys to SSH. So now instead of it looking on disk, we're going to have it pull the keys from the database. The one argument, by the way, is the username that's trying to log in. So here's that script. This script is going to get run every time someone tries to log into this machine using SSH. And it's fairly straightforward. Argument, $1 is the argument, the username. Then we're going to get the host name. We'll show you why that's important. Then if this is an Amazon machine, we're going to get the instance ID, which is available through the metadata server. So that's that first curl, which is local to the machine. We're going to take all that data. That's where the second curl comes in. We're going to take all that data. We're going to send it to the key server, to the key database, and see if there are any keys for this user available. So here's the example request at the bottom. It's going to make a request to your key server, getting some SSH keys. User is Aren, host name is prod-db-1, and the instance ID is whatever your instance ID is on Amazon. So with that information, we can start building rules. So here's our new diagram. We've got an API key in between the Linux server and the SSH key database. And here's what that endpoint looks like. Pretty simple. Grab those variables we just passed in, get the user from the database, decide, is this user, it's a simple question, is this user allowed on the host that just made this request? Pretty straightforward. If so, return the keys, and it's returning the keys in this format, right? So it's just like it was reading the file on disk, but it came from that script, so that's just it's returned as a HTTP response. This is, this is Django-ish, could be Flask, could be Node, could be whatever you like to write APIs in. So now, improving our diagram a little bit, we're going to apply on the top. Now we need to keep a database of rules. Who's allowed on these machines, when. We mix that in with the API, the key response. And this is where you get to use your imagination on what kind of rules you want to plug into your system. So let's talk about some options. We brought up some of these, but we'll spell them out. So to check if the user is still employed, you could use your API on Google Apps, G Suite, whatever they call it this week, Office 365. Maybe you have some other way, like an HR system that you can plug into. So start using all these APIs that are available to you to start building these rules. Okay? This maybe should be check number 1 if you're building this. All right, another rule. SSH key rotation. How many here have systems to actually rotate SSH keys? Be surprised if I see too many hands. Yeah. So we could argue whether this matters or not, but the reality is if you have any sort of auditors for compliance, they care. It's on their checklist, and if they care, that means you might have to care. Now we have a built-in system to cause it. We store a timestamp with every SSH key upload. When you're 90, 180, 360 days are up, a key never gets returned. Built-in key rotation. All right, pretty basic. Your time limit has exceeded. You're allowed on that host or those group of hosts for 24 hours. After 24 hours, that key is not going to be returned anymore. You can't log in. This is where it gets a little interesting. So all this data that we passed in, username, host name, instance ID, we can start using for pretty cool features. So based on the host name, we can start creating what we call host groups. So a group of all prod machines would be a very horizontal group. Right? And that's the first example. So you can define these with regular expressions against the host name. So in the first example, production machine would be the regex that starts with prod and has a hyphen and then anything after that. So our example of prod-db1, right, we know that's a prod machine. We can look in our rules database and say, does this user have access to production right now? And that's how we can grant access or not grant access to this production machine. The bottom example, we could turn this into what we call more of a vertical rule. So is this user should be able to access database machine vertically throughout any of the environment, prod, staging, dev. So maybe we'll have a regular expression that says the database, if it has the word -db-, we decided this is the database host based on our naming convention, can make a rule based on that. We can do the same thing, like this is taking a very Amazon-centric view, but we have that instance ID. What can we do with it? Well, we can take that instance ID, we can go to the EC2 API, we can trade that instance ID in for VPC ID, subnet ID, machine tags, all sorts of cool stuff. So now rules can say, I'll know it's a production machine if it's in the production VPC, or if it's in the production subnet, or maybe it has a production tag on it, right? Lots of information can be gleaned from, especially the tags API on Amazon. So again, plug that in as one of your rules. All right. Is this user on call? Go check your PagerDuty, your OpsGenie, your VictorOps API. Figure out if this user's on call. You know, some people think this is the dumbest idea they've ever heard of. Some people think this is pretty powerful. Love to hear your thoughts on it. But if you really want to make sure that when you're on call, you have all the resources you need, and when you're off call, your key leaking is not a big of a risk, this might be for you. I use Jira as an example here. It could be, you know, any of the many ticketing systems that have an API. But this is great for workflow. Someone needs a very important patch done on a very important machine. You can open a ticket, have it approved by the proper people. That grants access to that machine for a short amount of time. The work is done, the ticket is closed, the access goes away. Right, it's a recurring theme here. Access is granted, access goes away as soon as it's not needed. Again, this user has not made this request for a long time. So they used to have this permission, we thought it was important, but it's nice that all these permissions just atrophy over time if they're not being used. So that way, the set of access that a user has is very focused around what their work is right now. Sorry. So the possibilities are sort of endless here. These are the stuff that I've come up with. Love to hear your thoughts on other APIs you could plug into this system. And so, in summary, you want to make your access grants very specific as you can. So we've given you a lot of tools here to like focus them vertically, horizontally, whatever makes sense for that employee. You want to make them as temporary as you can. So ideally, they only need them for just the amount of time that they have them for only the amount of time they need them. And that way, if the master key leaks, that way if a user's key leaks, you know that it's not the master key in this scenario. All right, that's the end. Thank you very much. If you like this system and want to build it for yourself,